Next, we want to see what happens when we add some other numbers to our equation y equals x squared. So keep in mind, we saw that the axis of symmetry is that vertical line that goes right through the middle of the parabola. So whenever we graph a parabola, we're going to get a vertex. We're going to get this shape that looks like this. That's our parabola. And there's a line that cuts in half, and that's our axis of symmetry. All right. It cuts it exactly in half. All right. So let's look at these situations here. And we want to find the equations for the axis of symmetry. We want to figure out how it relates to these coefficients a and b in the equation y equals ax squared plus bx. We should have an x in there. We'll add that in there. All right. So we're looking at equations in this form. So here we have coefficients. Now remember, the coefficients are the number that is in front of a variable being multiplied. So here the coefficient is 1. Here the coefficient is -2. This is a special coefficient. This is called a leading coefficient because it's in front of the x squared, the term with the biggest power. All right. Well, where is the axis of symmetry? The axis of symmetry right here is at 1. So here we have an axis at x equals 1. Remember, the axis of symmetry is an equation. We'll abbreviate axis of symmetry AOS, right? Not to be confused with AOL for you people who have been around a while. All right, so AOS, that's line that cuts in half the axis of symmetry, x equals 1 in this case. All right, here we change the equation a little bit. Now we got x squared minus 4x, and we ended up over here at the equation x equals 2 for our axis of symmetry. And if we go plus 6 squared, notice this was over to the right of the axis, so this was positive. We got x squared plus 6. Well, that's coming over here to the left side of the axis. Here's our axis right here, our y-axis. So this is at -3. So our axis of symmetry is at x equals -3. Well, do you see a connection with that b value? This -2 gave us +1. This -4 gave us +2. This +6 landed us at -3. So it looks like it's half and the opposite sign, huh? So it's -1/2 of this. So we start to see connection between the b value and what that does to the x value there. The x value of that axis of symmetry, we should say. So it appears that the axis of symmetry has something to do with half of the b value. And we can kind of see that here. As we go to Desmos, and if we move that b value here we have a b value of 2. The axis symmetry right here is -1. All right, so that's our axis symmetry. Okay. And if we move that b value, the larger that b value is, it will move to -2.5, so it keeps going over to the left. And as that b value goes to -3, okay, so if we go like -4, now the axis symmetry is at 2. If we go to -7, the axis symmetry is at 3.5. All right, so if we bring this back to like, let's say -1 there, okay. So what happens with the axis symmetry? Let's go to -2. Okay, so there's our axis symmetry is at 1, which is half of this, all right. And what happens here, let's just see as we move that a value up. So that a value shrinks it up a little bit there. So the smaller that a value is, it moves away. So the a value affects it as well. So it turns out that we'll just leave it at this. The axis symmetry is -1/2 times b over a, or -b over 2a is where that ends up. All right. So here's what we're going to do to find the vertex, which is an important point there. We need to, first of all, have our standard form equation. And we can find the x-coordinate of the vertex at negative b over 2a, because that's where the axis of symmetry is. The axis of symmetry is at x equals negative b over 2a. And then our process is going to be this. So we know that when we have a quadratic function, we're going to have a parabola. So we're going to find the axis of symmetry. And the key here is that the vertex is always on the axis of symmetry, or the axis of symmetry passes through the vertex. So once we know that we found an axis of symmetry, we can find the vertex will be our goal. And once we find that vertex, then we can graph the rest of the parabola pretty easily from there. So the goal is to find the axis of symmetry and then use that to get the vertex. And every parabola will have a maximum or a minimum. Okay, a minimum would be the lowest point, like this graph has a minimum. If a parabola is upside down, it will have a maximum. Okay, so maximum or minimum depending on the a value, all right? So this graph right here has a minimum, and if we had a different parabola that was upside down, this here will have a maximum. That's the highest point on this parabola. This has the lowest point is at the vertex. Always happens at the vertex. All right, so what we're going to do here is we're going to go ahead and look at these equations, use these equations to find the axis of symmetry, the coordinates of the vertex, and then we're going to find that minimum or maximum value and then sketch a rough graph. Not necessarily in that order. Okay, we definitely want to find the axis of symmetry first. So the axis of symmetry is at x equals negative b over 2a. So that's a little formula that we'll want to memorize. And so we're going to plug in our negative 4 because our b value is 4 and our a value is negative 2. So we have 2 times negative 2. And that's just negative 4 over negative 4, which is 1. So we know that our x value is 1. Now it's actually a good idea to go ahead and let's start sketching our graph as we do this, because we'll get a good picture of what's going on here. So at positive 1, we have our axis of symmetry. Now we know the axis of symmetry goes through the vertex, so the vertex lives somewhere on this line. Well, we know the vertex happens at x equals 1, which is our axis of symmetry. So let's plug it in and let's find f of 1. All right, axis of symmetry there. And so we have negative 2 times 1 squared plus 4 times 1 minus 5. And 1 squared is 1, so times negative 2, that's negative 2. 4 times 1 is 4. Okay, so that ends up being, 2 minus 5, which is negative 3. All right, so down here at 3, again, just getting a rough graph. There's our graph. There's our vertex. So our vertex is at an x value of 1, which is the axis of symmetry, and a y value of negative 3. So there's our vertex. Now we know that the a value is negative 1, so this opens down. All right. And all right, so that's enough there. All right. Oh, it's what's got a maximum. That was another thing that happens. The max value, that's the highest y value, is at negative 3. So the highest this will ever get is negative 3. And it's a maximum, not a minimum, because that's the highest point because it's upside down. Okay, so it opens down because a is negative 1. All right. Well, how about our next one here? Let's find our axis of symmetry here. We've got x equals negative b over 2a, which is negative 2 over 2 times 2, which is going to be negative 2/4, which simplifies to negative 1/2. So now we got the axis of symmetry at x equals negative 1/2. We found our axis symmetry. Now our vertex, to find our vertex here, we got to plug that in. All right, so we're going to find f of negative 1/2. Got to work with some fractions here. Going to plug in negative 1/2 for our function here. Oh, I'm sorry, this function here. So we have 2 times negative 1/2 squared plus 2 times negative 1/2. Be real careful with your arithmetic here. So this is 2 times negative 1/2 squared would be 1/2 times 1/2, which is a fourth. And this is going to be negative 1, because 2 times 1/2 is 1. And so it looks like we got 1/2. 2 times a fourth is a half. Minus 1 minus 15. And that's like a half minus 16 there. So that's going to be negative 15.5. All right. All right. So that means our vertex is at negative 1/2 and negative 15.5. All right. So we can sketch a graph here of this. Negative 1/2. So our axis symmetry is at over here at negative 1/2. All right. So I guess this will be 1 right there. All right. And our vertex is at negative 1/2, negative 15.5, somewhere way down here. All right. If this is 15 and this is 16, just get an approximate sketch. What's our A value? A value is 2, so it's going to open up. Remember, a positive A value, it opens up. And since it opens up, not worried about the exact shape right now, that is a minimum. So we know we have a minimum. The lowest Y value is at negative 15.5. All right. That's the lowest the Y will ever get. Okay, the vertex always gives us the minimum or the maximum. All right. So there we have it. That's using the vertex and the axis symmetry. Another important point is the intercepts. So the intercepts are where it crosses the x-axis. So when we want to figure out what's going on here, we want to kind of know where it crosses the x-axis here. And we're also going to want to know where it crosses the y-axis. Okay. Now, if we think about, let's look at this little sketch here. All right. So if we think about where a graph crosses the x-axis, and again, this is not exact. Okay. This is our x-intercept. And the x-intercept has a y value of 0. Same thing over here. And then we have a y-intercept. And at a y-intercept, well, that's going to be somewhere that crosses the y-axis. So the special thing about those points is that the x value is 0. So the opposite coordinate is always 0 for the x and the y-intercept. So that's the key. All right, so when you're looking for intercepts, remember that to find the x-intercepts, f of x is 0 or y is 0. To find the y-intercepts, x is 0. So let's practice this. Let's find some exact x-intercepts and y-intercepts. Now we've got to keep in mind they're exact here. Okay, so probably the easiest one to find is the y-intercept. So let's start with the y-intercepts. To find the y-intercepts, we want to make x equal to 0. So we're just plugging in 0 for x. And all that means is we're just going to work it out. When x is 0, what is y? Well, this is 0. 3 times 0 is 0. Minus 10. And so this is just negative 10. So the y-intercept is going to be at, when x is 0, y is negative 10. There's that. Well, to find the x-intercept now, or x-intercepts, plural, we're gonna want to set y equal to 0. Now remember, f of x represents y, so we're going to have 0 for y equals x squared plus 3x minus 10. And now we have an equation that we need to solve. which will either be factoring or using the quadratic formula in most cases, or we could use a square root method sometimes. In this case, I think we can factor two numbers that add to negative 3, positive 3, and multiply to negative 10. And I think that 5, positive 5, and negative 2 will do it. They multiply to negative 10, 5 times negative 2, and they add to positive 3. So then how do we solve that? Well, we've got to make x plus 5 equal to 0 or x minus 2 equal to 0. We add 5, or we subtract 5 to both sides, and we get x equals negative 5. We add 2 to both sides, and we get x equals 2. So when x is negative 5, this whole thing becomes 0. When x is 2, this whole thing becomes 0. So we have 2 points for our x-intercepts. Negative 5 gives us 0, and 2, 0. All right, so those are the coordinates. Sometimes we'll just give the x value, but the coordinates are a little more exact. All right, let's try one more. You might want to pause and try this on your own if you want. Find the x-intercepts and the y-intercepts. So the y-intercepts, once again, we want to plug in 0 for x. So g of 0 is 2 times 0 squared plus 0 minus 2. And that's just 0 plus 0 minus 2. So the y-intercept, when x is 0, y is negative 2. There's our y-intercept. Now our x-intercept, we've got to set this equal to 0. All right, so we're going to have 0 equals, so this is for our x-intercept. We're going to have 0 equals 2x squared plus x minus 2. Now we could try to factor this. I don't think it's going to work, but we could look at it here. So if we're going to factor it, if it will factor, then it'll have to be 2x and x. And then this will either have to be, we need a 1 times a 2, because it got to multiply to negative 2. All right, it could be in that order. We can make this positive and this negative. This is going to give us negative 1x. This is going to give us positive 4x. And that does not add to positive 1. And we could move things around. We could maybe make this a 2 here and a 1 here. But I think any way that we go here, that's going to make 2x, and that's going to make negative 2x, and that does not add to 1. So any way we go here, it's not going to work out. So it's worth taking a look, but it doesn't work. So we'll need the quadratic formula. So we've got x equals negative b, which is a 1, plus or minus the square root, b squared minus 4ac, all over 2a. Remember that quadratic formula? 2a and a is 2. And what do we end up with? We get negative 1 plus or minus, and in here we get 1. This is going to be negative 4 times positive 2 times negative 2. That's going to be a positive 16, I think, right? Positive 16 all over 4. And in the end, we have negative 1 plus or minus the square root of 17 all over 4. Okay, so that is an irrational number. So we have two x-intercepts. The first x-intercept is negative 1 plus the square root of 17 all over 4, 0. And the second one is negative 1 minus the square root of 17 all over 4, comma 0. Two x-intercepts. Okay, all that means, if we go to our calculator and we punch in negative 1 plus the square root of 17 all over 2, that should give us, there's one number, 1.56, negative 1, let's go get it. Negative 1 minus the square root of 17 Too many negatives there. -1 minus square root of 17 all over 2. That's going to give us -2.56. And so that's where it will cross the x-axis. Now let's just test it out real quickly and we'll wrap this up. Y equals 2x squared plus x minus 2. There it is, and let's see. Uh-oh. Uh-oh, something happened here. Did you catch my mistake? You see my mistake? I didn't type this in right, so my calculations were right, but it's over 4. There it is. So we had our 4 right. We had our answers right here. I just didn't type it in right. Okay, now we're looking good. We got 0.78 and -1.28. So the moral of the story is these are just points. There they are. All right, now we match. There they are. 0.781 and -1.281. Those are the values. The exact values are 1 plus the square root of 17 and 1 minus the square root of 17. All right, well, we'll leave it at that. So that's how we get the intercepts by plugging in 0 for x or 0 for y. Always plug it in the opposite one there. And we can see how we can find the axis of symmetry and the vertex with -b over 2a for the axis of symmetry, and plug that in to find the vertex. Now we can find all our important points. And we'll see that these important points tell us a lot about what's going on with the function. Not so much to get these pretty pictures, but so that we understand what's happening to the function and we can use them in lots of different applications. I hope that helps. Thanks a lot.